In this video, we're going to continue on with our Portland data of rainfall. The mean annual rainfall is 40 inches with a standard deviation of 8 inches. Shade and find the cutoff values for part A is the lowest 10% of rainfall, and we could call that the 10th percentile. So I'm just going to shade down here in this tail, and this is 10%. So remember probability percent, that's under the curve, and then we're trying to find some value x that falls at the 10th percentile, and we want anything below. That will give us anything below. So we're going to use Staplet for this instead of GeoGebra, just because Staplet is much more user-friendly, and GeoGebra is a bit finicky for this. So if we go into Staplet, we're going to go staplet.com and then probability normal distributions. And instead of calculating area under the normal curve in the drop-down menu, we're going to choose calculate a value corresponding to an area. I'm going to put in the mean as 40, standard deviation as 8, and then we're going to plot the distribution. We'll get our picture with all our values there. And we need a left tail, and that will be an area of 10%. So we're going to put 0.1, we put it in as a decimal, and then we calculate our value. So our value is 29.74759. And incidentally, it gives us the z-score here as well, which is quite nice. We have z equals negative 1.28155. So you can see how that compares in a standardized form, kind of like when you have to compare apples to oranges. You could use the z formula that we've used previously, but you can also find it this way, which is really nice. And we'll do that in another lesson. Our answer for this one is the cutoff value for the lowest 10% of rainfall is 29.74759 inches. And we can round that off to 2 places. So I'm going to go ahead and change that to 29.75. So be sure to write the units so that it doesn't get confusing that that's a percentage. And we're clear that we're finding the cutoff value. So anything under that is in the lowest 10%. Now, you could do a similar thing here for part B, the highest 5% of rainfall, or the 95th percentile. You would go ahead and just mark a random spot and use the Staplet software, but you're going to pick the right tail, the right side. So go ahead and pause the video and try to do that on your own, and then check back. So in Staplet, we have again calculate value to corresponding area, put the mean and standard deviation in, plot your distribution, and then choose right tail, and the area goes in, 0.05 goes in as a decimal, and then calculate value, and we get 53.15883, and that is inches. And notice our z-score is in the positive here, 1.64485, so that's important information that you might need in a different type of problem for comparison purposes. So I'm just going to go ahead and copy that and write that for my answer. And I'm going to round off here. The cutoff value for the highest 5% of rainfall is 53.16 inches. And looking at our diagram, that sounds reasonable, because remember our mean is 40 and we know it should be to the right of that, right? If it's higher than the 50th percentile. So part C says the middle 50% of the rainfall. So that's not saying exactly what the middle is, it's just saying that middle chunk. So the whole area being 50%, not the halfway mark, not meaning median mode. So we can use GeoGebra for that as well, but we have to pick in the drop-down menu, we need to pick central, and then we're going to pick 0.5 here, and then make sure you hit calculate value again. And so we have two values here. Make this a little bigger for you. We have 34.60408 less than or equal to x less than or equal to 45.39592. And again, there's our z-scores for comparison, so it's symmetrical, so it will balance. And that makes sense. It would be a little below and above the mean. So check for reasonable answer. Make sure you didn't put a typo in. Make sure you hit to calculate again, and that your mean and standard deviation are correct. So I'm going to just copy that and push it over here. And then I'll write it in a sentence. If you can write it in a sentence with meaning on your own, pause the video and then check back. So a sentence could be something like the middle 50% of rainfall lands between about 34.6 and 45.4 inches. I've just rounded off those values to the nearest two places, but when I rounded, it would be actually, I can write that in there as 0. And that's really all there is to it with finding these values. It's pretty straightforward and nice. The key thing is you need to understand what's happening and why we're choosing the highest or less than or more than or the middle. So as long as you know how it lays out, then you're good. So this one, actually a graph down here, we would have just kind of marked in a random spot. We don't exactly know where it would sit, but we have an idea that it would just be the middle 50th. And now that we have our values, we could kind of judge, but we typically do the shading, just block off a couple of lines, do the shading, get an idea of how it should sit, and then make sure that matches up. The middle one is a little trickier to show than the other ones. But what you can do for your work is to show either your drawn sketch, what you've entered into Staplet is really important to paste somewhere. It is often challenging to get it to fit in the Word doc easily, so you could use Microsoft Edge and just put it on top. It works out really nicely. However you want to make that work out. The next thing we're going to do is look at the standard normal model Z. So if we have to compare things like apples and oranges, we can just boil it down to the standard deviation Z-score, and to find out how many standard deviations each event is away from its mean. And then we can use that for comparison. We did something similar to this before when we were doing Z-score by the formula in another lesson. But now we can actually use Statlet to find that as well, so that will be even nicer. So here's an example. We're going to assume the average annual rainfall for Portland is 40 inches with a standard deviation of 8. So we still have that same data, but we're going to also assume that the average wind speed in Chicago is 10 miles per hour with a standard deviation of 2 miles per hour. So we want to compare these two. Suppose that one year Portland's annual rainfall was only 24 inches and Chicago's average wind speed was 13 miles per hour. Which of these events was more extraordinary? So you can tell, like, well, that's pretty low, that 24 inches. That was really on the low end. And wind speed of 13 miles per hour on average compared to 10. How does that compare? Is that a big deal, or which is the bigger deal? So we can use the z-scores to compare how many standard deviations it is away from the mean. So first thing we want to do is figure out the z-score for 24 inches of rain in Portland. We already have our Statlet set up, but just a reminder, it'll have the old data and process we were using for the previous problem in there already, so we need to change that. So we want to go up here. Operation would be calculate area under a normal curve. Click the plot distribution is already there. And instead of between two values, we want to know to the left of a value. And we're going to put the value in. It will give us the probability, but it'll also give us the z-score. Right there, z equals -2. So that's really nice. And we get the area as well. We get a sketch, so you can always do screenshots and put that to show as work for your notes, your participation classwork, as well as any quizzes that you might be working on. Then we need to compare the other one as well. We're going to put the wind speed for Chicago in there. I'm going to jot this down first. Okay, so a couple things to note before we go into Statlet, that we're doing this Chicago problem. So we need to look at what their mean is now 10 miles per hour. So we're going to add that in there, enter that in. And the standard deviation is 2 from the problem. And we're comparing to 13 miles per hour. So I'm going to go ahead and hit a new plot distribution there. So I have the Chicago data. And we're putting in 13 and calculate the area. And we still want the left of a value. And we have z equals 1.5. Area is 93.32%. So we can enter that right down here. So what we're looking at is which one's further from the mean. And we can have a visual here to see that the -2 z-score is further from the mean. So Portland would be further than Chicago, the z-score of 1.5. The mean, when we have z-scores, is, remember, at 0. And standard deviations are 1 unit. So this shows that Portland had the more extraordinary event. And this can be used for all sorts of different cases, so it's important to be able to figure out the z-scores. You can just do it by hand on a calculator, crunching the numbers as we've done previously, but it's nice if you have Statlet out, you could just pop it in and then you get the nice visual as well, and other information that you may need for a different part of the problem. So a couple of things to note: that standardizing into z-scores does not change the shape of the distribution of the variables. It does change the center by making the mean 0. It changes the spread by making the standard deviation 1. So just some things to note that these numbers would need to change. But the shape stays the same. Please note that we do not use the charts and the tables that you may have seen in some old books or videos, or maybe a solutions generator or ChatGPT may be giving you some things like based on older methods. So don't use those. We're just going to use technology, or you could crunch the numbers and find the Z, but then to use that Z for information like we're going to do now, is like to find a probability and such, we're not going to use tables. So I'll show you when we have a question that is just based on finding like probability when Z is less than or equal to, for example, 1.5, what would that look like? So again, we're going to use the normal distribution model, and we have a mean of 0, standard deviation of 1, and we note this with n parentheses 0, 1, just like before. And so if I were to put this into Staplet here, I would actually just change my mean to 0 and my standard deviation to 1, plot distribution, and there it lays out for you. And if I want to find the area to the left, let me get rid of this before, I'm going to put in the value 1.5 is my z-score, and I get my probability here, 93.32%, which is what we had previously based on the data for the Chicago, but you're not always given the actual mean and standard deviation. You're given like the z-score. So when you're given a z-score and you need to find the probability, you can calculate the probability by putting mean as 0, standard deviation as 1, and then putting in the z-score as your value instead of the actual data value variable. So then we would just write area equals 93.32% as our answer. Here's another example that you could try on your own or do it along with me. If you want to do it on your own, just pause the video. But we have a z-score between negative 0.3 and 0.5. So we can just go into Staplet. We already had our mean set to 0, standard deviation to 1. But instead of calculate area to the left, we need it between two values. And our left boundary is negative 0.3. And our right boundary is 0.5. And I'm going to calculate area. You can see the graph here, so you could do a screenshot of that to show your work. And then our area is 30.94%. Here's another example. Okay, one last example here. An incoming freshman took her college's placement exams in French and mathematics. and we need to compare them. We want to look at which one she did better compared to the other freshmen. In French, she scored 82, and in math, 86. So those were her, X values. The overall results on the French exam had a mean of 72 points and a standard deviation of 8 points. The mean math score was 68 points with a standard deviation of 12 points. On which exam did she do better compared with the other freshmen? So this is very similar to the rainfall compared to the wind speed. And what you could do is first find the Z-score for the French grade exam, and then the Z for the math exam. So you're going to enter the information, the given information, into Staplet for one, figure out the Z, and then for the other. You wouldn't want to try to combine them all up together. So we'll count this one as more of a classwork. So go ahead and try that. Pause the video and then check back. Okay, so just a reminder, we would have the score of 82 for French and mean of 72, standard deviation of 8. So we're going to want to make sure we hit calculate an area under the normal curve. We're putting in the given mean and the given standard deviation. And then we can hit plot distribution. And that lays out the scores for us. We want to calculate the area to the left of the value, and we put the value in as 82. And this will give us our probability, but also give us our Z-score. So we have a Z of 1.25 for the French. So now we'll go through the math. If you didn't do one on your own yet, try to make sure you can get those values in there for that. And we'll do the math. So you can pause the video and do that now if you haven't done it already. So math was 86 for our mean. No, that's our score. But our math mean was 68, a little bit lower there. Standard deviation was 12 points, so a bigger standard deviation. We want the left, but our score is 86. And we're going to calculate area, but it will also give us our Z-score of 1.5. Okay, so the Z for the French exam was 1.25, and the Z value or Z score for the math test was 1.5. So the math was relatively better compared to other people. Okay, so you can simply write a sentence here: the math score was better compared to the other freshmen. And that's it for this video set. Have a great day.